Find the first four terms of the sequence given by the following. Before I begin, I want to remind you that a sequence is actually a function whose domain is often the set of natural numbers. So I'm going to write the domain here. And the way we write the set of natural numbers is this double bar n. And then we write equals, and then we put a set here, a set brace. And then we start listing the natural numbers. And if you put 3 dots there, that means it goes on forever, 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 forever. Let's go ahead and find the first 4 terms of the outputs. So the outputs, you could think of the outputs being on the y-axis, but the outputs here are called a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on and so forth. Let's find a sub 1. We are simply evaluating an expression here. A sub 1 is equal to 43 minus 6 times 1 minus 1, which of course is 43. Therefore, a sub 1 is 43. Let's find a sub 2. A sub 2 is equal to 43 minus 6. 2 minus 1, of course, is 1. So do the order of operations. Do inside the parentheses first, and you'll notice you'll get 57. Therefore, what? A sub 2 is 57. I'm actually going to summarize it at the end. That will make things easier. So let's find a sub 3. A sub 3 is equal to the next expression, which is 43 minus 6 times 3 minus 1. And of course, do order of operations first. So 43 minus 12 is 31. So a sub 3 is the expression 31. In this problem here, you're just simplifying 4 expressions. Let's simplify the 4th expression. A sub 4 is equal to 43 minus 6 times 4 minus 3 is, 4 minus 1 is 3. So we have 43 minus 18. What is 43 minus 18? 25. Yeah, that's correct. All right, now let's write our final answers. A sub 1 is equal to 43. A sub 2 is equal to 57. A sub 3 is equal to 31. And then a sub 4 is equal to 25. Yeah, wait a second here. Something doesn't seem right. 43. Haha. 43 minus 6 is not 57. Shame on me. What's 43 minus 6? 37. That sounds better. This was an arithmetic sequence, and remember, in an arithmetic sequence, there is a common difference. So if you notice that here, D is what? D is going to be the common difference, which is negative 6, right? A sub 2 minus a sub 1, which equals negative 6. Same thing here. Notice there's a D here. D is equal to what? A sub 4 minus a sub 3, which is also negative 6. So you could see the common difference. So that's how I was able to realize that one of my numbers must have been miscalculated. I'm ready to circle that as my final answer. Now, just to remind you what a function is just a set of ordered pairs that must pass the vertical line test. So this right here is the n-axis. And then over here, this is now called the a sub n axis. So your domain values are simply these little tally marks. Like that. And of course, these keep going on forever and forever and forever. Now, if I wanted to, I could put some outputs here. I could say, here, why don't I break this up as well as I can. This is obviously a little sloppy. 10, 20, 30, 40. And so when a sub 1 occurred, well, you were up here. You were at this dot here, this output here, 43. And a sub 2 is 37, and so on and so forth. But notice this is not continuous. So there's 37, and then 31, and then what, 25. And so notice this is not continuous. In fact, if it's an arithmetic difference, it almost looks linear, but decreasing, right? And so we can't really call it linear because it doesn't represent a line. This is a function that is not continuous. And so last time you heard about continuous was something called a continuous exponential growth model or a continuous decay model. Well, sequences are functions that are not continuous. In fact, they're just little dots that pass the vertical line test. So that was just a little bit of additional information for you guys to get a better idea of what sequences are. Even though I circled the final answer, you definitely want to show this work here. So I'm going to circle that as well. There you go.